Hi, welcome back to my Intro to Python tutorial. Today we're going to be talking about classes and objects. So what's a class? More to the point, what's an object? So an object is an instance of a class. An object can have functions and it can have properties like a name. So here we've defined a class called dog. So we're going to make some dogs. So we have a type of object called dog. And we've given it a function called doBark. This self here we'll explain later, just ignore it for now. When we call doBark, we want it to print out woof. So the way we make an instance of a class is we put the class name and bracket. So here we instantiate dog and we store it as my dog. Instantiate just means make an instance of. So we define a class, we make an instance of it, and then we're going to call a function on that instance. So what we expect here is when we call mydog.doBark, Python goes off and it says, right, I know my dog is of class dog, it looks in class dog, it finds the method doBark, and it runs it. So we expect it to print woof. And it does. So we said that objects can have methods and functions. They can also have properties. So here we give the dog a name. And each dog that we make can have a different name. So initially we instantiate dog. And when we make it, name equals blank. So then we give the dog a name. So why don't we add a line in here before we give it a name? Just going to delete these guys for now. So before we give it a name, my name is, and then it just prints nothing. Get rid of this guy. If we name him Fido, it says my dog's name is Fido. And we can change that property as well. So we can rename the dog to Rex. So again, we have a class called dog. We make an instance of it, and then we can manipulate the variables inside it. If we do something like print mydog.age, when we haven't actually defined a variable called age, we'll get an error. If we say mydog.age equals 7, you might expect to get an error, but Python just says, you know what? That's cool. I'm going to create another property inside this particular instance of dog called age, and I'm going to assign it 7. So you can actually create these things on the fly. You just can't reference something that hasn't been created because it's not there. So now we come down here, and one important property of classes is you can have more than one of them. And this is the reason we do this, and we don't just use a dictionary, right? So we have a class called dog, and we make two of them. We have dog1 and dog2. We set dog1's name to Fido, dog2's name to Rex. So now we have two variables completely separate from each other. We can do different things to them. We can use them in different ways. So we'll print out, I have a dog called dog1.name, and I also have a dog called dog2.name. And here we say I have a dog called Fido from dog1 and Rex from dog2. Cool. So that's pretty simple. We can use those properties in the functions. So here we've said we're not just going to give the dog a name, they're also going to be able to bark different ways. So when we call doBark, it's going to say, well, do I have a name? If it doesn't have a name, it'll print the dog has no name. If it doesn't have a bark, it'll print the dog has no bark. If it has both, then it'll print this out. Notice this elif. This just means else if. So if one thing, otherwise if this thing, otherwise if neither of them, do something else. So that's the elif. So here, I've just got a note here that there's a useful thing you can do in Jupyter Notebooks, which is splitting cells. If you can't remember these shortcuts, that's fine. They're a bit annoying. You can right click, go to notebook cell and say split cell. So this way I don't have to delete this stuff down here if I don't want to run it. So now we're creating a dog and we're saying do bark without setting name or bark, right? So we expect it to come in here, find the do bark method and say self.name, hey, it is empty. So we expect it to say the dog has no name. Cool. If we set the dog's name, then again, we know what's going to happen here. Sorry. So here we've got an error, right? We've set dog to a string after actually instantiating it. Then when we go to do bark, Python says, hey, a string doesn't have an attribute called do bark. What the hell are you doing? So I actually meant to say dog.name equals Buster. Now when it comes through, we actually know what's going to happen. And it says the dog has no bark. Cool. So my dog.name.bark equals woof. So now it's come through and it said, right, I see it's got a name. I see it's got a bark. So I'm going to come through to here and say name says bark. And we get Buster says woof. So let's get rid of these. Let's rejoin to this next cell. We don't have to. We could just run this and then run this and it would work. But I feel like rejoining them. So I'll go to notebook cell and I'll say join with next cell. So same kind of thing. Dog's name, Fido. Dog's name, dog's bark, woof. Fido says woof. So critically, this is a trivial example, but what we've done is we've created an object. We've stored some information in there, a couple of different things, and then we've used them in a function. So you can do some cool stuff with that. We can give a class a constructor. A constructor is what's run when you do this, when you call dog bracket bracket. And it can actually take some arguments, right? So it can take a name and a bark as arguments. So down here, when we create the dog, we pass in the name, we pass in the bark, and they get assigned to name and bark. Now, the reason this self is here is because when we define variables, we define them as name, we define them as bark. If we just said name equals new name and bark equals new bark, the scope of these variables would only be the function that it exists in, the code block that it exists in. That means that when it reaches the end of its scope, so when it reaches the end of this code block, they would disappear. The way we read and write variables that belong to the object, not just to this code block, is to use the self keyword. So that's why we have self as the first argument to any method or function that is going to be run on the object itself, not on the class. So you can have class functions, we'll talk about them later. But if it's an object function, if it's something where we're going to be storing something that is unique to this instance of the dog, not to all dogs in general, then we have self at the start. So now when we create the dog, Python goes off and says, right, he wants to make a dog, and he's given me 2 arguments. So it goes into dog, it finds the constructor that takes 2 arguments, and it does what we tell it. It stores name, and it stores bark. We've passed them in as new name and new bark, and they get stored to here. So when we create our other dog, we pass in 2 different things. We call it Frank, and when Frank barks, he says, make me a burger, Dino. When we run it, we see Fido saying woof, and Frank saying what Frank says. So this is very similar to what happened up here. We could have done this just by creating 2 things and assigning them a name and a bark. But critically here, I can't make a dog without passing these 2 things in. So if I say another dog equals dog bracket bracket, and I try and run this, Python says, well, hang on a second. Init, so the constructor, is missing two required positional arguments, new name and new bark. So it's saying, hey, you need to pass these two things in. So we could drop these two, but equally someone could come along and say, okay, you know, I'm going to pass in some junk and then I'm going to unset them later. So here, our code would still say, well, hang on a second. Nope, didn't work. Oh no, third one, we never said bark. So now when we run this, we get the dog has no name. So constructors are a good way of grabbing the information you need at the start of the process and making sure that you have it later. So we'll just run this. So now we have my dog and my other dog as variables. We can put them in a list. We call that list my pack because it's a pack of dogs. And then for dog in my pack, print out the dog's name. So you can put objects in a list and you can use them like any other element in a list. We can also loop through that list and make some changes. So for dog in pack, so the first time through this list, my dog will come out as dog. We'll set my dog's bark to woof, and then we'll make it bark. And then it'll go again because it sees another element. My other dog will now be stored as the variable dog. It'll point to that guy. We'll make his bark woof as well, and then we'll make him bark. So now we can see they both have the bark woof. Cool, so that's pretty trivial. Let's make a person. That sounds a little more complicated, right? So a person's going to have a name, and we're storing none. None is empty. It's not an empty string. It says, I haven't assigned to this. It's nothing. It's null. So generally, you would never want to print a null variable or add it to another one. It says, hey, I'm not initialized. Please don't use me. We're defining a constructor that requires us to pass in a name, a height, a weight, and an age. It's good to store your units, sorry, just to comment in your units here. So we're putting height in centimeters, weight in kilograms, and age in years. And we're defining a function, which is kind of like our bark function up there, that just say hello. So each time we make a person, we will call the constructor like we do down here. We will have to pass in a name, here it's Joe, a height, here it's 180 centimeters, a weight, here it's 76.3 kilograms, and an age, here we've got 34. So we make a list and we append some people to that list. So we've got Joe, Daniel, Sally, and we want to print out that list. Now, when we printed out a list of numbers, we got a square bracket and then the numbers between the square brackets. When we printed out a list of strings, we got a square bracket and then we got the strings between. When we print out a list of objects, it's not as pretty. So it just says this thing here, right? So this is a memory address that we're stored at. This says our class is person, and it's part of our main function here, or main module, or main function, I think. But this isn't very useful, right? So we want to add something to this person class that tells Python how to print it out when we need to print it to the terminal. So we add this underscore underscore repr, which is representation. Now you see our system methods functions starting with underscore underscore and ending in underscore underscore. That's usually done to make sure that you as the programmer don't accidentally overwrite them. So unless you're doing something pretty serious, try not to start and end your function names with double underscore and you'll be safe. So here we're doing the same thing. We're creating some people, we're putting them in a list, and we're printing it out. But now when we print it, we expect to see a person called and then the name of the person. And it works. our list is a person called Joe, a person called Daniel, a person called Sally. Now, you could also print out their age and their height, their weight, and whatever you wanted in here. But it's just an example of how to print things out nicely. This is great for debugging and figuring out what the heck's going on. If I wanted to figure out the average age, then there's a way for me to do that. I mean, I can do it the simple way, right? I can just loop through the list. I can keep count of how many people I've seen. I can keep count of the total age, and then I can divide one by the other. Now, if we look at the actual ages, 34, 42, and 33, if we add them up, we've got 67, we've got 109, divided by 3, we'd expect this to be 0.33333 recurring. This 6 at the end is pretty far down. It's not going to make a difference to us too often, but this is an artifact of how floating points are stored. They're not guaranteed to be completely accurate. And the bigger the number, the bigger the number on this side, the less accurate the fraction on this side. And actually, the bigger the number, the less accurate the whole number. So just remember that if you're doing things like financial maths or nuclear physics or whatever, you're going to end up with an accumulated error here, and it's not going to be particularly predictable. So there are better number types to use if you need it to be correct. Whereas floating point is pretty fast because there's hardware in the CPU to handle floating points. So here we have a class called dog and a class called person. And so far we've seen a dog have some properties, a person have some properties, but we're going to do something new here. We're going to say that a person can have a pet. And we're actually going to store the pet in this variable. So it'll be a pointer to that object. It won't just be a number. It'll actually be a reference to the dog object. So we're going to make ourselves a couple of people. We're going to put them in a list. We're going to make ourselves a couple of dogs. We're going to put them in a list. We're going to add pet Fido and add pet Dino to Joe. If we go look what add pet does, get rid of some blank space here, it just says append the pet onto my list of pets. Now the list of pets starts as an empty list when we run the constructor. So we'll just append Fido and Dino, or Dino, however you want to pronounce it, to this list of pets. And when we get down here, what we'll see is that this will actually look something like this. And when we print joe.pets, we'll see a dog named Fido and a dog named Dino. And that's because we've also added into dog this function here that tells it how to print it out, just like we did with person. So now we've stored a reference to another object, in fact a list of references, in that person. And we can do something like for dog in joe.pets, dog.doBark. So each of Joe's pets we call a function because it just comes out as Fido and Dino. And we know that if we did Fido.doBark, we'd see Fido says woof. And if we did Dino.doBark, we'd see Dino says arf from here. So this is kind of what this looks like. We've got a list of dogs. We've got an object called Joe. Joe has a name. He has a height. He has a weight. He has an age. And he has this property called pets. And pets is just a list of a couple of dogs. And Fido has a name. Fido has a bark. Dino has a name. Dino has a bark. So what if we wanted to go through the dogs, or go through and find Fido's owner? We had a list of people we wanted to go through, and we wanted to say which of these people owns Fido. Well, we could go through the list of people and say for person in people, if Fido is in their list of pets, then say that person owns Fido. So we run that and we find Joe owns Fido. So if we take a look at the list people, Joe's the first person in it. So the first time through the loop, we'd say, hey, is Fido in Joe.pets? And would get true because it is. And it would print this out. Now, if we had a long list of people and a long list of pets, that'd get pretty expensive. And by expensive, I mean it'd take a while to compute. So maybe we want to store a reference in the dog to who its owner is as well. So we'll have a reference from the person to the list of dogs that they own, and each dog will also have a reference back up to their owner. So here in class dog, we're going to add an owner, and then when we print out Fido.owner, we get none because we haven't set it yet. Then in person, we're going to modify this add pet function to say, go off and set the property on that pet, set the owner property to self. So whichever object we call add pet on, and we pass in the new pet. So we're going to call Joe. We're going to add the pet, pass in Fido. It'll go off to Fido and set the owner to the object that we're currently running on, which is Joe. So this is getting a little bit complicated, but not too bad. We'll see how it works. And we'll see that we create a person.joe. We add a pet called Fido. And we see that his list of pets is a list with a single entry, Fido. And when we check Fido's owner, we now get a person called Joe. And that's because when we called add pet on Joe, it said, right, I'm going to add him to the list, but I'm also going to go off and tell Fido that his new owner is Joe. So now we can find the owner of a pet much more easily because we're storing a reference for it. We don't have to search for it. So that's classes and objects. We did some cool stuff there. The next course is going to be on generators and yield, which is a cool way to do some of the things we did here, like calculating an average, which we did up the top. And it also introduces you to the way that Python likes you to think, which is pretty cool.